And good morning. All right, let's go ahead and start with section 3.3. Now today we're going to put together equalities and unknowns. All right, so let's get in our book here. Should be on page 64. It's time to now look at equalities that include unknowns. We're going to use the same principle of adding, subtracting, multiplying, dividing both sides of an equation by the same quantity to find the value of an unknown. Okay, let's say we're trying to save $19 for a purchase. We've saved $13 so far. How much do we have left to save? So this is definitely something that you could just solve mentally, but they're wanting to actually show it to you in pictures to help you kind of understand it. So we're going to look at the scale. We know that 13 plus a quantity, which here is represented by x. So 13 plus some number is going to equal 19. Let's turn the page. Now, the question is, how do we find x? Okay. Remember, if we add, subtract, multiply, or divide both sides of an equation by the same quantity, both sides will stay equal. So, if we subtract 13 from both sides, we'll be left with x on one side. Since both sides of our equation will still be equal, the right side will then show us what x equals. So they're subtracting 13 from both sides. See, they're keeping it equal. But once they take those off of here, it shows you what x is equal to. Okay? We now know that the value of x is $6. So if we substitute this value back into the original equation, it holds true that 13 plus 6, remember this was x, but they're substituting in the number they got to stand for x, and 13 plus 6 indeed equals 19. Now, you should be going, wow, right now, because of the consistent way that God holds the universe together. We can rely on these operations to operate so consistently. We can subtract the same quantity from both sides of an equation and still be confident that the answer is still going to be in balance. We can use that answer to tell us the value of an unknown. Now, this technique of separating an unknown on one side of an equation in order to find its value is one that you're going to be using very extensively. While we illustrated it using subtraction, since that was the easiest to show visually on a scale, the same principle applies though with other operations. So here's our gray box we need to read. Now, to find an unknown in an equation, get the unknown on a side by itself. Do this by performing the same operation using the same quantity to both sides of the equation. Now, most of these you can find mentally. Knowing how to find an unknown by oscillating it on one side of an equation will help you solve problems that would be difficult to solve later on. It's a technique you're going to use a lot, and one that ultimately works because of the consistent way God causes objects to add, subtract, multiply, and divide. Now, I'm sure you'll agree it's not practical to draw a scale every time we want to find the value of an unknown, nor is it necessary. The scale was simply a visual to show that process. So now we're going to walk through it on these examples without a scale. So here we have x plus 13 equals 19. So to find the value for x, we want to oscillate x on a side by itself. We know that x plus 13 equals 19. That's what this equation shows. So if we subtract 13 from both sides, we'll end up finding the value for x. So they've written it like this. So x plus 13 minus 13 equals 19 minus 13. Notice how they've subtracted the same amount from both sides. Now let's simplify. 13 minus 13 equals 0, leaving us x plus 0. Or more simply, x on the left. So x is by itself. These cancel each other out. And then 19 minus 13 equals 6. Leaving us $6 on the right, so then we're left with our answer. X equals $6. Now you could have used cross-outs to show, just cross out what cancels each other out. Nonetheless, you still get x equals 6. Now, then to check it, you would plug back in what you got for x to make sure that it all works out. And for x, you got $6, so you would plug this $6 back in here, and you would add it up, and yes, 6 plus 13 does equal 19. So your math was done correctly. So that's how you check it, is you plug those numbers back in. So they're showing you what they did. So here they have 13 plus x equals 19. Took away 13 from both sides. We're left with x equals 6. Okay. Next page. Now this is the understanding the why. This is very important. So many times you think, well, why am I doing this? Well, let's find out why. Now it's easy on that scale to see how subtracting 13 from both sides found the value for x. And some of you might be wisely wondering how that works mathematically. After all, the order of operation says to add and subtract from left to right. So in x plus 13 minus 13, we should add x and 13 first and then subtract 13, right? True, except remember that we can think of subtraction as an addition of a negative number. And that addition is commutative and associative. Even though we didn't write out the plus sign, and most people don't, we were really viewing the subtraction of 13 as an addition of a negative 13. Thus, we were able to add $13 and minus $13, which equals 0. Because if you think about it, think about a number line. Here's 0 right in the center. I'm just thinking of this, okay? And let's say you go to 13, positive 13, and then you're going to add negative 13. Well, that means you go back to 0. And that's how that works. So you might also wonder how we knew mathematically what number to subtract. Well, as we saw back in lesson 2.4, the additive inverse is the name we give to the number that added to another equals 0. We know that positive $13 and negative $13 are additive inverses. So by subtracting $13, which we can think of as adding a negative 13, we got 0. And since adding 0 doesn't change the value of the number, there's the identity property of addition. We knew adding plus 13 and negative 13 would leave us with x, because x plus 0 simplified is just x. Nobody puts the 0 there. So the properties and the principles we looked at in the first two chapters are ones that we'll rely on again and again. And why can we rely on these properties and principles to work? Because God is governing all things in a consistent and predictable way. Once again, our ability to use math ultimately goes back to God's faithfulness. That's true. Let's look at this example. Here we have x minus 2 equals 4. So to find the value for x, you want to isolate x on a side by itself. We know that x minus 2 equals 4. So if we add 2 to both sides, we'll end up finding the value for x. Now you simplify, so you're going to add 2 to both sides. You can just cross these out like they did here. Okay? Or you can leave it this way and you can simplify, whatever you want to do. But nonetheless, you're left with x equals 6 because these 2 plus 2, or excuse me, negative 2 plus 2 gets you to 0. So they cancel each other out. So you're left with x by itself equals 4 plus 2, which x equals 6. Okay? And then, of course, again, you can check your work. This was your original equation. Then you got x equals 6, so you can just plug 6 into the x and work the equation. And it does equal, so you did everything correctly. So, if you perform the same operation using the same quantity to both sides of the equation, the sides remain equal. But why? Because God holds creation together in a consistent, predictable enough fashion we can rely on the fact that if we perform the same operation using the same quantity to both sides of an equation, they'll stay equal. So every time you're doing that, you can think of God's perfection. Okay, so let's look at our worksheet. Worksheet 3.3. Probably you'll be able to use your calculator somewhere because it mentions it here. So finding the unknowns. Solve each equation for x, that is, isolate x on a side by itself so as to find its value. Show how you added or subtracted. Okay, so in other words, show your work. So here we have an example, x minus 3 equals 10. So this is what you'll do. X minus 3 plus 3 equals 10 plus 3. Whatever you do to this side, you got to do to this side. And then x, because this cancels out, equals 13. Okay, now here is one that we're going to do. Let me get my notes, or my pen, I mean. Okay, so x minus 7 equals 20. Here's an example that would go with this. How many brownies were there before dinner if your family ate 7 brownies after dinner and you've got 20 left? All right, So this is what you write, okay? Now get used to this and don't skip any steps, okay? Rewrite the problem, okay? Figure out what you're going to do. In this case, we want to get x by itself, so we'll have to add 7 to both sides. So we're going to rewrite it. Minus 7 plus 7 equals 20 plus 7. Okay, if it's easier for you, cross that out, and then you're left with x by itself equals whatever this equals, 27. Now, obviously, when they're numbers like this, you don't have to check it. I mean, you can check this in your mind. 27 minus 7 equals 20. Yes, that would be correct. If these are great big numbers, you might want to check it. But, you know, stuff like this, you can just check in your mind. All right. So, that's what you'll need to do on the rest of these. This one here gives you an example meaning. Now, remember, if it's plus, then you'll want to do the opposite. If it's subtraction, of course, you want to do plus. Now, on this part, it says to go back and check each of your answers. Okay, well, I didn't realize it was going to have you check your answers. So basically, on A, you'll go back up here, and you'll take x. Okay, so you'll just plug the numbers in. So on A, this is what you would write. 27 minus 7 equals 20. Now, they're wanting you to write the whole shebang out, wanting you to write the original one, and then what you did, and blah, blah, blah. You can do it this way if you want to, but, I mean, you can just plug your numbers in. It doesn't matter when they're these little numbers, but it'll matter when the numbers get larger. Just as long as you know how to plug those numbers back in to check. All right, look at the next page. Let me see. I don't know how many pages there are of this one. Okay, there's just 2 pages on this one. All right, so there you have a challenge problem. I think you can answer those. Okay. All right. I'd like for you to, here's where you can use your calculator. Okay. I'd like for you to finish this worksheet yourself. I think it's pretty easy. I think you should be able to do it. If you have any questions or you run into a problem, just let me know. Or you can look back in your book. But I think that is all for today. I'm not going to grade it, but I do want to see it. Just want to make sure you get the hang of doing this. Okay. All right, that's all for this lesson.